Alright, so let's go through the second question of our coordinate geometry, which is, I would say, rather difficult. Okay, so we have a line connecting A and B, right, meets the x-axis at C, and of course, the point P lies on AC such that AP and PB is 3:2. Okay, find the coordinate of point P. How do we do this question? So every time you see like you are given ratio, then after that you can see a bit of triangle thingy, right? Is high. They are actually testing you on your congruency and similarity. Okay, so first, when we are talking about similarity and congruency, right, we want to find one big triangle and one small triangle. Okay, the big triangle that we actually want is actually the AB. So if you look at this, right, AB, the total ratio is 5. What about the small triangle? The small triangle actually is right here. So from A to P. Okay, so let me just draw sketch a bit. So AP, right, is 3. Okay, next we'll be finding the scale factor, meaning that we want to find how much bigger is the big triangle compared to the small triangle, right? So the scale factor will be 5/3. The big triangle is about 5/3 times bigger than the small triangle. So each of the length will be 5/3 times bigger than each of the length of the small triangle. Okay, so now let's determine our coordinate P first. Okay, based on this diagram, right, okay, let me just sketch a bit of the big triangle on the diagram. So for this, you sketch like that. Okay, so this is the big triangle. Okay, so big triangle, maybe I just shade here. Okay, so first thing first, I want to find what is the height of this big triangle, meaning from here all the way to here. Yeah. So based on the diagram, you can see, okay, my y coordinate, because I want to find the height, means you look at the y coordinate. Don't look at the s coordinate. Later we'll look at the s coordinate. So the y coordinate is 11 all the way to 1, meaning 11 minus 1 is 10. Alright. Okay, what about the horizontal? Horizontal will be from look at the B until A, right? So the x coordinate, so 0 to 5 will be 5. So now I know all the different lengths of the big triangle already. Okay, so now it's time to find the length or the height and the base of the small triangle. Okay, so this is where the scale factor comes in. So scale factor means if you look at all the different lengths, meaning 10 and 5, right? So the big triangle is 5/3 times longer than the length of the small triangle. So for this part, okay, this small triangle, right? Okay, let's determine what is the height. So, okay, the height is 10 times 3/5. Or you can just 10 divided by 5/3, doesn't matter. Right? Okay, so if you calculate correctly, you should get 6. Yeah, so the height of the small triangle is 6 units. So if you don't believe, if you use this, right, 10 divided by 6, you see whether you can get 5/3 or not, which you can get. So now I know that the so-called this height, right? So this height is 6 units. So based on this, actually I can determine my y coordinate of point P already. So okay, erase this first. Okay, looking at point A, I go 6 units down. So I go 6 units down, right? So it means that my y coordinate 11 minus 6, which will give me your 11. Okay, it's 5. Yeah. Okay, then you put a comma. Okay, now it's time to determine what is your x coordinate of your P. Okay, so this is where I need to look at this part already. So 5 times, right? I mean 5 units. So how do I find what is the length of this horizontal length of the small triangle? You simply just use 5 times 3/5. Or you can just use 5 divided by 5/3. Doesn't matter. Same thing. As long as you must have a number or answer smaller than 5. Then that's the answer. So it's 3 units. Yeah. So this part, so from here all the way to here will be 3 units. Okay, so now it's time to determine what is our x coordinate of P. So based on this, right? Okay, 5. Here is 5, right? So you go 3 units towards the left. Because this is 5. Then after that, here will be roughly 2. So these 2. So the x coordinate of P is 2. That's how you find. So for first part, it's actually testing you on your congruency and similarity. Okay. Okay. So now let's move on to the next part. The next part also quite difficult. Okay. So let me just draw another diagram. So for this diagram, okay, let's draw. Okay. So they ask us that they tell us that okay, the original line is here. Okay, then after that there's a extra line here. Okay, so this is your P, point P. So point P, we have determined our coordinate, which is 2, 5. Alright. Okay, so they say that a line through P passes through the x-axis at Q, which is here, and angle PCQ, so this C, so PCQ is equal to PQC. Find the equation of PQ, which is this part. Okay, so how do I do this question? Okay, first thing, this is actually testing you on whether you know this thing. So for example, right, this one is your tangent x is equal to the gradient. So what do they mean by tangent x is equal to m? Very simple. First, let me just write down A. So 5, this is 5, 11. Then of course I got point B, right? Point B is 0, 1. Okay, so what do they mean by x? So imagine I have I draw a right angle triangle. Okay, so this is your right angle triangle. So of course, to find the gradient, you want to use the rise over the run. So rise over run, right? We know that is the gradient. And of course, example, let's just say I have an angle here. Let's call this angle x. So how do I relate the angle x with the gradient? Very simple. So we know that under tua ka so, right? Tua ka so. Okay, tua ka so, okay, so we know that this is also considered oppo. This is also considered, the run is considered your adjacent. So if you use oppo divided by adjacent, you can actually get your tangent x. So tangent x is equal to oppo, which is the rise, divided by run. So in this case, right, we know that rise over run in our coordinate geometry is your gradient. So that's how they actually derive tangent x equal to gradient. Alright. Okay, so based on this concept, let's determine. Okay, so I erase this first. Okay, based on this concept, they tell us that, I want to find the gradient of PQ, right? Okay, so first, we know that this is angle x. And okay, based on this formula, right, tangent x is equal to gradient. Let's find what is our angle x first. Okay, first, find the gradient of AB. So the gradient of AB, if you calculate correctly, 11 minus 1 over 5 minus 0, which will give you positive 2. So this is positive 2, meaning that the whole of this length, the whole of this gradient is positive 2. Okay, so how do I find x? So very simple, angle x, right? So tangent x is equal to positive 2. Then so of course you just inverse the tangent. So tangent inverse 2 is equal to, let me just calculate. So this will equate to about 63.43494.882 degree. Alright. Okay, so this part will be 63.43 something. Then of course this is because the same angle. Okay, next part will be based on this idea, right? I want to calculate what is the angle right here. This is what I call the obtuse angle. Alright. Okay, the obtuse angle is 180 minus 63 point something, right? So let me just calculate. 3494882. So this will give you roughly 116.5650512 degree. Why do I want to calculate the 116? Very simple. Because you want to find the gradient of your PQ. So this is a gradient of PQ, right? Okay. So so for this, always remember whenever, so the x-axis, right, is here. Then after that, right, so if I have a gradient like this, So the angle x is actually calculated from here. It's always with respect to the x-axis, right? You go your anti-clockwise. This is the meaning of your angle x. So for example, right, if you want to find the gradient of this line, given that this angle is maybe, let me just quote them, 63.4 degree. So the gradient, you simply just put tangent 63.4 degree equal to your gradient. What if I'm given this situation? So if I give you this situation x, right, but now the gradient is like that. So the gradient is like that, right? So you must actually start calculating from here. So imagine that this is the 116 just now. Okay, let me just write down 116.5650512 degree. Okay, based on this idea, I calculate. So tangent 116.5650512 degree will be the gradient of our PQ. So this is something that we want to find. Okay, so you sub everything in. So tangent 116.5650512 bracket. So you will get roughly the gradient is equal to negative 2. Alright? Yeah, so now we already know, okay, my PQ, the gradient is negative 2. Okay, how do I find the y-intercept? So we have already finished the most difficult part of the question already. So the gradient is negative 2, right? Okay, the y-intercept, you simply just sub in 2, 5. So for example, right, let me just, okay, so for example, this is your PQ. So gradient is equal to negative 2, right? So y is equal to negative 2, x plus c. Then we know that, okay, my point P, let me just quote 2, 5. Okay, 2, 5. So 5 you sub inside here. 2 you sub inside here. So 5 equal to negative 4 plus c. So c is equal to positive 9. Yeah. So in this particular question, right, my equation of PQ is negative 2x plus 9. So that's the answer. Yeah, so that's the answer for your the first part. Okay, now let's determine what is our Q. Coordinate Q is simple because coordinate Q is just this part. So it's just where did I intersect the x-axis. So always remember, you want to find x-intercept, you always sub y equal to 0. Of course, you need the equation of PQ. So sub y equal to 0, so you sub this, right? So it's equal to 0 equal to 2x plus, okay, negative 2x plus 9. So 2x is equal to positive 9. X is equal to 4.5. So do we need to find y coordinate? Don't need, because it's the x-intercept. So x-intercept is, we know that y coordinate is always 0. So the x, the so-called coordinate of Q. Always remember, coordinate of Q, you give them two numbers, 4.5, 0, bracket. So that is how you do this question.